So looking at variables in C, really we're just saying that we have some sort of data in memory and we want to give it a human readable name. And what I mean by that is saying I have a variable, I want an integer called foo, and I'm going to give it a value of 5. Now, if I go and debug this, just write it and make it, and then debug it with GDB, I can go to line 6, run it, and if I look at the address, so the ampersand tells me the address of foo, it's telling me that at this memory location, this value, I have 4 bytes, because size of integer on my system is, for legacy purposes, 4 bytes. And the value in there stored is 5, right? And so, but it's easier for me to say like, hey, I want to store 5 as foo instead of I want to put 5 into the memory location, and then I'll just have a heap of hexadecimal memory locations, and no way I can keep track of that, right? So human readable, very easy to follow. They have different data types, and the data type is specified at the beginning of the variable, right? So this is an integer, char bar, this would be a character, and I can store the character A in it. And so really what it's doing is it's just telling me how many bytes. So if we look at printf, foo is bytes and bar is bytes. So now if we just run this, we can see that foo was 4 bytes and bar is 1 byte, right? Because we're only storing a 1 byte character. And so A can have, we'll look at the value of A, because we're storing it as the ASCII character A, which if we look at ASCII table, we'll see that A, I think, has a value of like 40 something, or like it's lowercase, so maybe it's like 90 something. My computer struggles so hard with screen recording going. So we'll just finish this while I'm waiting. Bar is, we'll just say, I think it's C, print a character, bar, right? So we can make this, and so bar is A, or we can then typecast it to be an integer, and we'll say int bar, and it will give us the ASCII value for it, I'm pretty sure. Because if we look at the ASCII table, we'll see we have lowercase a here, so we have a value in decimal of 97. And that's exactly what we have. So as a character, it's A, but as a decimal value, it's 97. Okay, cool. So then this is like the data type tells us the size in memory, the amount of bytes that it stores. We have a human readable name, but the data type also tells us the range of the variable, like what's the maximum number. And so we have an integer, or let's say even better, we have a char called bar, right? So it's an 8-bit. If we say this is an unsigned char to make it even more precise, it's an 8-bit value that stores the value between 0 and 255. So what happens if I want to put in 256? So we'll say bar equals 256, right? And I'll try and compile this, or it should compile, but it will give me a warning. And what it's going to say is that I'm overflowing, right? Because if you think about it in binary, as soon as I go from 255 to 256, I have 1, 1, 1, 1, 1, 1. I have 8 ones, and then as I go up 1, I just put the ninth bit as 1, and then go back to 0. So I'm overflowing my 8-bit value down to 0, right? And so when I then go and print bar, if I put him here, we'll see that I've overflowed it, and I'm back at 0 because it's only taking those 8 bits, because the data type that I gave the compiler, this char, unsigned char, saying, hey, when I do operations on bar, only give me 8 bits, right? So this is when the variable has a data type, like all variables need some sort of a data type. And the other thing that it shows, like a variable has, is the operations that can be performed on it. And this is also based off of their data type. So character, right? So I could then take bar and I can use the increment operations. This means +1. So this is the same, put in a comment, this is the same as bar equals bar +1. And this is also the same as bar plus equals 1. Right? So if we run this now, we've overflowed our value to 0, and then we'll get it back up. We'll print it again. Oh man. So we've overflowed it to 0, and then we've incremented it to 1. But this incrementation is legal, right? But let's say that we have a float. So a float is a decimal point. And so we'll say we have a float called foobar, and we'll make it equal to 1.1, right? So now, if we want to do like a bit shift, which you would do on like a 1, so we can say bar bit shift equals 1, and then we'll print this again. We'll run here, and we'll see that we've now bit shifted 1 to 2, so we've taken that first bit and just shifted it over 1, which makes sense. This is a valid operation on a character operation. But if I run that same one on foobar, shift equals 1, I will get a compile error, because this operand, or this operation, is not valid on a float. You can can probably force it. So if I go integer foobar, will this let me do it? No, still not. So in this saying, the variable has certain operations to be done on it, and it's based on this data type, right? So hopefully that makes sense. I'm going to leave this line commented out because it is not valid, and with it we can't compile and run our program.